why am I giving a title, Understanding the EV Elephant? It will become clear as we go on. And towards the end, I will talk about this title. But in a very simple manner, what I am going to talk about, that our vehicles, which are IC engine vehicles for, I don't know how long, 60 years, 70 years, long or longer, are likely to become all electric in coming decade, 10 years, 12 years, 15 years. And the question that I am going to ask to the project management group, that are we ready for this transition? I don't know whether transition is considered as a project management exercise, but it's very similar to a project management exercise. So are we ready for this transition, and why will this happen, and how will this happen, and what are the challenges that we'll face? It is going to really be huge. In some sense, if you are not prepared, it can mean immense amount of disturbance. I remember sometime about, not a year back, maybe a year and a half back, I had gone to Delhi, became principal advisor of Shri Piyush Goyal, that time Minister of Power and Renewable Energy, and was given a charge that, well, figure out whether electric vehicles will happen, and if it is going to happen in the world, how do you see this to happen in India, and what do we need to do? I was given a full charge. And I went around talking to industry. The word was that, well, EV will not happen, not soon. Electric vehicle will go through the hybrid route, which will be a little bit of electric, but primarily IC engine vehicle. It's actually, electric vehicles are very expensive, and these are true statements. It will require 30 to 40% subsidy. And in United States, Europe, and in China, that kind of subsidy is being provided, and therefore slow transition is taking place. In India, even the charging infrastructure is not ready. Industry was therefore largely disinterested. And about 4 or 5 months back, I had a gathering of some of these companies out here, 50 Indian companies, and look at it, these are Indian companies, not multinational companies in India, not largely Indian companies, which was gung-ho about electric vehicles, working very hard, certainly believing that electric vehicle is going to happen, and if we do not prepare for it, we will perish. Why so? I don't know how many of you know, the auto industry today in India is 7.3% of India's GDP. 7.3%. And if I take into account the petrol industry for fuel processing, for just the processing of the fuel, transport of the fuel, and distribution of the fuel, that's almost about 5%. So we are talking about 12.1% industry riding on existing autos industry. And if the transition is going to happen, and if you are not prepared, you are going to just collapse. And that's very substantial industry. So suddenly you found that industries like Ashok Leyland, Tata Motors, Mahindra, Eicher, Bajaj, Lohia, Electrotherm, Goenka, Heroico, Okinawa, Ather, Avon Cycle, TVS Motors, and one can go on and on. Almost all, if you look at Indian industry, not the industry which is a type, not Maruti. I didn't mention Maruti here. I didn't mention Toyota out here. Even though Maruti is very much an Indian company, it depends on for the thought leadership from outside. Anybody who had a thought leadership in India suddenly started believing the electric vehicle is going to happen, and either you get it there or you are going to lose it. And it is not just the vehicle industry, the battery industry. In the beginning, I remember in about a year and a half back, they were disinterested. Exide, Amar Raja, today they are running after it. And new companies, Exicom, Acme, Green Tech, Green Fuel, Ion Batteries, Athero, Sun Mobility. energy operators came in, new industries. SL Infra, I am going to talk a little bit about them. Sun Mobility, BPCL, NTPCL, PGCL, these are the electric companies. These are the electricity distribution company. Suddenly they seem to be getting very interested. The chargers and motors, Delta, Acme, Exicom, TVS Motors, it is TVS, not Motors, TVS Lucas, Council Neoward, Valeo, and a number of state government and STUs suddenly got extremely interested in that electric vehicle. What happened? Why is this transition took place and what happened? Basically, the first thing was that everybody recognized that electric vehicle is the future. There are some people still trying to deny it, but if they internally they realize that electric vehicle is the future. Why? For simple reason. Electric vehicle has electric motor has about 90% plus energy efficiency. Any IC engine has an efficiency of 20, 21, 23, 24%. So you have 4 times more energy efficient. So as long as you can actually do this economically, things will move in that direction. Electric vehicles are far more reliable. It has 50 times less moving parts. IC engine vehicle has lots of moving parts. There is a lot of wear tear. Of course, design has to be very careful. So basically, they are energy efficient, they are more reliable. As long as the cost becomes competitive, the transition is going to take place. And cost was very quickly moving towards that. What was happening is that the cost 3-4 years back, 5 years back was very high, probably 3 times the IC engine vehicle. Today, it is probably 25-30% higher. But you can see the downward trend, and you can see that electric vehicle very soon will be lower cost than IC engine vehicle. Now, lower cost, more efficient, far more reliability, far superior performance. What is going to stop it? That is what started getting recognized. And as I pointed out, the full economy depended on it. And when the transition takes place and if you are not prepared, you are gone. So in some sense, I thought that the project management group should really look at that there is a transition coming and it is an opportunity for them to actually help in the transition. There is a problem. As I pointed out, however, today the cost is 30-40% still higher. And therefore, in India, what will you do? Will you bring this kind of subsidy? In the West, this kind of subsidy exists. In US, this subsidy exists. Europe, this subsidy exists. China, this subsidy exists. In India, such kind of subsidy is not going to happen. I spent time at the finance ministry looking at what can possibly happen, came back with the conclusion that not only it will not happen, it is foolish to expect this, and it is not even desirable because we don't have that kind of surplus in our budgets. So we won't get the subsidy. Now, without subsidy, how is it going to happen when it is much more expensive? Because India's affordability is low, people are not going to buy a 40% more expensive car just because this may be the future. Few people may buy, but that's not good. I drive a vehicle 3 years back. I bought it at 40% higher than a IC engine vehicle, but it is not going to scale. So one thing that we recognize that EV must make business sense even in a situation where otherwise it will be 30-40% more expensive. And how do you make electric vehicle business sense? And that is a challenge that was thrown toward me. And I worked with the industry to try to sort of say, okay, how can this happen? And I'm going to tell you a story about what really happened and then link you to the last part, why do I call it a EV elephant? So basically, the key thing was battery dominated the cost. And look, is there a pointer? Is there a pointer? No? This one? Okay. Look at this. Look at this. The way the prices of batteries are falling, battery dominates the cost. Was 50% of the cost of the vehicle. And look at what's happening here. The way it is dropping, the cost is dropping. It is going to be, we know if we wait for 4 years, 5 years, it is going to be no more expensive than IC engine vehicle. But the question is today. If we wait, what will happen is because there is a subsidy in China, subsidy in Europe, subsidy in the United States, the transition will take place there. And then they will control the technology. And once they control the technology, everything will have to be imported. This was the biggest issue. Today, fortunately, for our auto industry, almost everything is made in India. There is a huge industry of auto subcomponents, a lot of it is in Tamil Nadu, and auto subsystems. All of that will become a problem. In 5 years' time, all of that can happen automatically. As 2020, 2022, you will see the battery prices falling, and then really it will happen. But then what will India get out of it? Indian industry can get badly affected. So it is in this context that we really looked at how we can make the transition. So the key challenge was, can India drive its EV program innovatively and differently? Why innovatively and differently? If it does it in the same manner, it will pretty much be the same situation where it is 30 to 40% more expensive than the IC engine vehicle. I'll go one step further. If you look at, in India, the lowest cost four-wheeler, for example, it is available around 3.5 lakhs. 3.5 lakhs will be how many? About $4,000, $5,000, $5,000. Which country a vehicle is available at $5,000? Why is in India vehicle is available? Because industry has worked, has carried out R&D and has worked because India's affordability is that. So we have no choice but to match the India's affordability. India's vehicle, large number of vehicles get purchased at 3 lakhs, 4 lakhs, 5 lakhs, 6 lakhs, 7 lakhs rupees. The question is, how do you make electric vehicles possible at that price point? That's a challenge that we have, and if we don't do that, then we will not get anywhere. Last 5 years, 211, 12 to 216, 17 figures. If you look at almost 75% of our vehicles, 79% of our vehicles are two-wheelers. And then there are three-wheelers, three-wheelers. So in India, most of the vehicles are two-wheelers and three-wheelers. And only about 14% are the cars. And even in the cars, if you look more carefully, 2% of the cars which are above $15,000, above 10 lakhs rupees. Most of the cars are below 10 lakhs. So, whereas if you go to the West, most of the vehicles are above $15,000. 20, 25, 30, 35,000, $40,000 will be the starting point. And the electric vehicles that are coming in the West starts at $30,000, $40,000. In India, even if those things comes in with subsidy, without subsidy, it will get into the market of 1 to 2%. And nobody in particular is working on two-wheelers, three-wheelers, and inexpensive four-wheelers. So in some sense, it gave us idea that we have to invert the whole thing, and we have to actually work on these kind of vehicles if you want to make a difference in India. So this is what I'm talking about. So 79% of our vehicles are two-wheelers, almost 4% are autos, 3% are buses and large goods vehicle, and 12% are cars which are less than rupees 10 lakhs. Only 2% are the cars which are above rupees 10 lakhs. So what is the thing that we sort of said? Well, for 98% of what I call public and affordable vehicle, we have to do something in India. We have to look at a different approach. For the 2%, we can pretty much, the approach is we could adopt the same approach that is done in the West, and we probably will find it difficult to beat them, and they can go, they will go much faster. But for 98% of vehicle, which is a very large numbers, can we actually do something? And that is the approach that we sort of said. So we started looking at it. Initially, it looked like impossible. Our vehicles has to be lower cost, electric vehicles are higher cost. We have to make vehicles and there will be no subsidy. All over the rest of the world, subsidy is there. So we had to do something different. So we got together all these companies that I talked about, Indian companies. we got them together and started brainstorming. What can we do? Can we really do something about it? And they all sort of said nothing can be done. But one of the things that came out, that the question that we started asking them, that okay, all of them were working a little bit on electric vehicle. Your electric vehicle, kitna deti hai? What is the mileage that it gives? What is the watt hour per kilometer it gives? Now, this question nobody had heard. Whereas if it was a petrol vehicles, they will all the time ask that question. And part of the reason why petrol was expensive, electricity was not that expensive, they said, well, it doesn't matter. What was pointed out to them, it does matter a lot. Because your cost of the vehicle totally depends on the cost of the battery. And cost of the battery depends on the size of the battery, and therefore it depends on kitna deti hai, what is the watt hour energy that you require per kilometer, electrical energy that you require. If you reduce that, your battery size will go down. If your battery size goes down, your cost will go down. So we started asking the question, watt hour per kilometer. We found out, for example, started with three-wheeler and asked this question. One person from TVS Motors got up and sort of said, well, it gives today it is 80 watt hour per kilometer. That means in 1 kilowatt hour, 1 unit of energy, we can get 12 kilometers. I turned around and sort of said, why? Why can't we get 20? Why can't we get 22? Why can't we get 45 watt hour per kilometer? This is impossible. I said, why is it impossible? Is there a fundamental reason that we cannot do it? And we went into that detail, and they came with the idea, well, it is doable, you require better motors, more energy efficient motors. You require better tires. You require then a car with a better aerodynamic property. If you do that, it is possible to reduce. But they said this kind of reduction is not possible. And the motor must give you that performance at all speeds. Not in India, you drive at very low speed. You don't drive at high speed. Now, this was a challenge thrown, and initially people sort of said not possible, till a startup got up and sort of said, well, I think I can make a motor in the three-wheeler, which can do almost 45 watt hour per kilometer. As soon as he said that, the established industry sort of said, all right, we also can do something, but it will be more, it will cost more. I said, don't worry about the cost. Let us see what is the most energy efficient electric vehicle we can make. We started looking at it, and in a year's time, the industry has come, reduced from 70 to 80 watt hour per kilometer to 45 to 50 watt hour per kilometer. What does that do? If you use less energy per kilometer, you require smaller battery. So what you do is that you knock out almost 35 to 40% of the battery. Once you knock out 35 to 40% of the battery, your cost goes down significantly. Battery was dominating the cost. Battery was 50% of the cost. And suddenly you realize, oh, you don't need to be so much more expensive as compared to a petrol vehicle. But still it was coming out to be expensive. Then we came up with the idea that why don't we split the batteries and use smaller battery. The question came, if I use smaller battery, I'll be able to go a smaller range. And then what will I do? Standing and charging will take a long time. It takes 1 hour, 2 hours to charge. I'm not going to wait there in the middle of the day. If I make it only 50 kilometers, I'll use it for 2 hours, and after that I have to go for charging. I can't wait for charging. Then we came with the idea, why not do battery swapping for three-wheelers? The question was, well, nobody else in the world has done it. 1 or 2 people tried and they failed. We tried to ask, what is the reason they failed? Nobody had clear answer. We went to a depth of it, and we actually failed because of various, they started too early, economic reasons were there, the things had gone. What is the fundamental reason? Most people sort of say, well, engineering wise, it is a challenge that can be overcome. I said, then why not overcome that? what will happen? You will require 1/3 size of the battery. And somebody will have to keep the battery ready, charged and ready, and swap the battery for you. But you require only 1/3 size of the battery. If you require only 1/3 size of the battery, your cost comes down. Basically, we found that subsidy will no longer be required. There was other advantage. The battery life is impacted quite a bit by the temperature. And if you try to charge it after the battery runs out, and you charge and the temperature becomes 42, 43, 45 degrees centigrade, the battery gets destroyed. But if you are swapping the battery, you can take the battery indoor. You can take the battery in an air-conditioned environment and then charge. Now, the battery life will not be impacted. So suddenly you started seeing lots of advantage. It was a challenge in terms of nobody has done it. Well, nobody has done it. It doesn't mean that, is there a fundamental engineering challenge? Is there a fundamental economic challenge? If not, it's a question of, I think you people know, how to get things done, how to initially get the things done. And very soon a concept came up that you separate the vehicle business and energy business. Let vehicle be sold without any battery. And let battery be available to you on hire, like your gas cylinder. You drive into a place, it gives you the battery, you drive. When you run out, you go to a place and it gives you back. And the business which runs the energy operator is called energy business. And we suddenly found that with this, capital cost of the vehicle becomes same as electric vehicle. No subsidy is required because you are selling it without battery. In fact, could be less than that of petrol vehicles. And the operation cost, when you hire a battery, you lease a battery for use. Cost per kilometer is same as a petrol vehicle. You don't require a subsidy. You are not dependent on the government. What about the person who buys the battery? The person, if they rent the battery out, they make money. They take the depreciation and the interest cost for the life of the battery, charge, discharge, and hand over the battery. And things work out quite well. This is something that we actually found doing well. Can I take a little extra time or no? Oh, all right. So once we figured that out, we sort of said, well, the key question came, but nobody else has done in the world. I said, so what if nobody else has done in the world? Can you not be the first people to do it? And you drive volume using this approach. You create a separate business called energy business. Somebody else will buy the battery and give it to you, and whole thing can actually start working. So basically, with that, no subsidy was needed. This would take care of three-wheelers, and surprisingly, even the buses. Buses also, if you swap the battery, essentially the cost is neither the capital cost nor the operation cost is higher than that of a petrol buses. So it's an engineering challenge to get the things ready and to get the whole operational setup where the swapping will take place, but no further challenge. What about private vehicles? As I told you, batteries dominate the cost of the electric vehicle, and the point is, vehicles like Tesla uses a 550 kilometer, 600 kilometer battery. And the cost becomes very, very high. The weight also becomes very, very high. If you use smaller battery, you are always worried, will you run out of battery? As I told you, if it's a public vehicle, it can swap the battery because it doesn't mind going out, and if it's a taxi, it can swap the battery. Private vehicle, you don't want to go twice in a day or once in a day, every day to swap the battery. What do? Well, you do something else. What if you make the battery small? You make the battery only for 100 kilometers. Suppose I have a four-wheeler and I have a battery with 100 kilometers. The question is, how many times I charge it in the night, how many times do I drive more than 100 kilometers? We checked out with the industry and we found not more than 5% time. So 95% of the days it will run quite well. You charge overnight and then you just have a 100 kilometer battery, cost will come down. And you charge it slowly in the night, there is no problem. For the day you need extra battery, for the day you need more, instead of charging, you swap in a battery. So you create a second slot in the vehicle. Instead of having one battery of 600 kilometer, you create a slot for two batteries of 100 kilometer each. One of them is empty, one of them is filled, one of them is sold to you. The day you need to travel extra distance and you realize that, oh, you are running out of the battery and you still have a day to go, you drive into a petrol pump, they add a second battery and you drive. And you return the battery. Suddenly the whole cost scenario changes. The question was, but nobody else has done in the world. And we actually checked out personal vehicles, and we did the same thing for two-wheeler. Instead of 100 kilometer, we did 50 kilometer. And people don't drive longer than that. Then, so essentially, India's task became very different. Most energy efficient vehicles, better motor and driver, better tires, lower weight, etc., etc. We said battery ecosystem, you get into pack manufacturing, cell manufacturing, materials and chemicals. We looked at charging and swapping infrastructure for range extension and demand generation policies. And we started looking at every aspect of it. And suddenly, it was a matter of a year and a half, you suddenly found that e-rickshaw and e-autos were getting ready. And with battery swapping. Similarly, two-wheelers came up with the range extension battery swapping. 50 kilometers you have a battery, and if you need more, you can get. And the cost becomes similar. Suddenly, the whole disadvantage goes in. Four-wheelers, you get a 100 kilometer battery, and built in, the cost becomes similar, 7 lakhs. A small car maybe 5.5 lakhs. And the day you want more battery, go longer distance, you add a battery. So that's what you can actually do. For buses, you can again do city buses. They go from ICF to Besant Nagar 10 times a day. At both ends, you swap the battery. You can actually handle the whole thing. The second thing was develop a low cost infrastructure. And every single thing starts making business sense. The key thing is everything starts making business sense. And as it starts making better sense, suddenly you see things one after another done. The most challenging thing was batteries. The question that was asked, are we going to import all the batteries? Instead of, India was not making lithium-ion batteries, you require lithium-ion batteries. Are we going to import all the batteries instead of making them, importing oil? The key thing was, battery making itself consists of three parts. One is called cell to pack, another is cell manufacturing, and the third is raw materials. This is 40% cost, 30% cost, 30% cost. Very quickly we got ready and started making the first part, battery pack development. Companies like Amar Raja, Exide, several other companies came up and said, well, this is something that we could design and manufacture. And believe me or not, 4 years back, about 3 years back, we are nowhere. Today, we make as good a battery pack as anybody else in the world. This is where our simple engineering talent really starts helping. Cell development, we have a big problem. Cell, we don't manufacture. We don't have the technology. So the question was, what do we do on that? Well, that's where we sort of said we'll get into strategic collaboration with companies. Because technology changes every 1.5 years. Trying to get, and by the time we even get something and use something, and if you don't do a tie-up, we will not be able to survive. The key thing was material. Material was 40% of the cost. Lithium, manganese, cobalt, nickel, and graphite. Unfortunately, India had no materials. India didn't have these materials. So what do you do? Well, we checked around. We didn't have the material. Piyush Goyal, who was my minister with whom I was working, was also Minister of Mines. We looked around. There was the materials was not there. That's the time we came up with the whole idea of battery recycling. Today, we have laptop batteries and cell phone batteries. These are lithium-ion batteries. We started working on technology to recycle them. And we suddenly were able to find that we are able to recover 95% of the materials and reuse them. We have 1 lakh ton of these batteries available today. Actually, if we start recycling them, and the technologies are available, there is industry which is making it and using that. Basically, what I'm talking about, challenges, you take tough challenges and do this. So industry has woken up and things are moving very well. the biggest challenge will be, how do you transform the small and medium industries, which are auto industry? They can collapse if you don't do anything about it. This is the kind of thing. Three-wheelers is the first thing. This is what is running for last 5-6 months at IIT Madras with battery swapping. We are taking measurements at every minute, every second of it, and getting data, figuring out what is going on, what is going right, what is going wrong. We have close to 200 million points of data about India with Indian temperature and all that, which nobody else has. We really understand, therefore, the behavior of the cells, behavior of the batteries, what happens, where the fault takes place, and all that. And with that, we are pretty much ready to launch electric vehicles without any subsidy. There is a problem. We still don't have an EV policy. There is a lot of talk, a lot of empty talk, doesn't get us anywhere. We do need strong R&D to commercialize an electric vehicle. We have to encourage electric production from renewable, watch out for new approaches and technology. But essentially, more needs to be done, time of essence. But I'll say in last 1 year, and this is my last slide, we have actually moved faster than we can actually believe. And we have been able to get ready. The point is, it's going to cause huge disruption in coming year, huge disruption. And therefore, there will be huge opportunity for project management to actually carry out the transition. I want to end by just telling you this story. See, we did all this, we were able to get the industry together. Unfortunately, once we were getting successful, suddenly things started not going on well in Delhi. There were 6 different ministries pulling things in different directions, each going and looking at something somewhere in the world and say, we know how to do electric vehicles, and they were pushing things in different directions. And things were falling apart. That's a time I remembered an old story called 7 Blind Men and the Elephant. I don't know how many of you remember that. There were these blind men who wanted to understand the elephant. Each of them went and touched the elephant, looked at different parts. One of them touched the tusk, another ears, and they thought that they understood the elephant. And then they described the elephant. And it sounds very funny when they talk about it, because nobody really understood the elephant. I realized that we are in the same situation. As far as the electric vehicle is like an elephant. Nobody understands that. Nobody has bothered to really understand it in depth. Everybody goes and visits somebody somewhere, Tesla, or somebody goes and visits somewhere in Japan, somewhere goes, and they all think that particularly all the bureaucrats, they think that they understand all the electric vehicles. And then they push policies. One of them is pushing in this direction, one of them is pushing in that direction, and things are just going nowhere. And we are in a totally confused state, the policy-wise. This is one of the worst things that I saw after so much work getting done. We are in a totally confused state. Somebody say we'll go in that direction, somebody goes in that direction. And when things were getting very bad, before I came back from Delhi, I actually started writing a blog called Understanding the EV Elephant. It has some 14-15 articles in a very simple way, explaining each point, why and what does the elephant. I call the electric vehicle is like an elephant. There are various elements of it. If you don't see all of it, you will land up not really understanding what it is. Thank you very much. I'm sorry for that.
Thank you, Professor Ashok. Thank you for helping us understand about the EV elephant. As a token of appreciation, we would like to present a memento and a spot event photograph on the conference to Professor Ashok. I now request Jawahar Venkatraman, Vice President Governance, to do the honors. Let's have a big round of applause.